Hello everyone. ዛሬ ይዤላችሁ የቀረብኩት ፊዚክስ ፎር ግሬድ 12 ሪቪው ኩዌስችንስ ዩኒት 4 ኤሌክትሮስታቲክ ፔጅ 161 ሪቪው ኩዌስችንስ ኤሌክትሮስታቲክስ the branch of physics that study about charges which are at rest is said to be electrostatics. Under electrostatics or under these chapters, electrostatics charges which are at rest, the force formed between charges, that is Coulomb's force, the direction of field lines are studied. Capacitor and the capacitance is also discussed under electrostatics. ስለዚህ በዚህ ሪቪው ኩዌስችንስ ነው ይዤላችሁ የቀረብኩት። ይሄ ፍሮም ፔጅ 161 ነው። ለዚህ ቻናል አዲስ የሆናችሁ ሰዎች ላይክ፣ ሼር፣ ሰብስክራይብ እንድታደርጉ ጠይቃችኋለሁ። ቀጣይ ቪዲዮ እንዲደርሳችሁ ማለት ነው። የመጀመሪያውን ጥያቄ እንሰራለን። Explain the meaning of terms electric field and electric field strength. The term electric field and electric field strength. Electric field is the region around a charged object where another charged object will experience a force. A region around a charged object where another charged object will experience a force. That is said to be electric field. ይሄ ማለት ምን ማለት ነው? Let's say this is charge Q. This charge Q is, let's say, positively charged particles. Field is away from positively charged particles, just like this. Pointed away from the charged particles and towards the negatively charged particles. So, around these charged particles, where another charged particles, let's say this is a test charge. Test charge is a positively charged particles, very small in magnitude, which used to test the direction of field line that is found in other charged object. The field lines that is produced by a test charge cannot affect the another charged object because a test charge is a very small charge. Therefore, around the charged object, let's say this charge, around this charge, where another charged object, maybe test charge, experience a force due to this charge is said to be electric field. ስለዚህ electric field ማለት ምን ማለት ነው? Around the charge where electric force can take place, that is electric field. That is electric field. Electric field strength is defined as electric field and electric field strength ነው እየለየው ያለሁት እዚህ ጋር the difference between electric field and electric field strength. Electric field ማለት around a charged body where another charged particle experience a force due to the charged object. ይሄ ምንድነው? ኤሌክትሪክ ፊልድ ነው። ኤሌክትሪክ ፊልድ strength is defined as force per unit charge. Electric field strength, which is symbolized by E, is defined as force per unit test charge. Force per unit charge acting on a positive test charge. This is positive test charge. Force per unit test charge is said to be electric field strength. This is the difference between electric field and electric field strength. Next question. Question number 2. A small conducting sphere is tied to the end of an insulating rod. Here there is a sphere. A small conducting sphere is tied to A small conducting sphere is attached to end of insulating rod. It carries a charge of 5 times 10 to the power of minus 9 coulomb. The sphere is held between two parallel metal plates. This is a sphere. ይሄ sphere ነው። Sphere is placed between two parallel metal plates. The plates which are 4 cm apart. ሁለቱ ፕሌቶች 4 cm apart ናቸው። 4 cm are connected to 50,000 volt supply. The difference in potential difference between the two plates are 50,000 volt supply. The potential difference between the two plates. So the question is, calculate the magnitude of the electric field strength between the plates. It says electric field strength between the plates. Electric field strength is equal to potential difference over the separation between the two plates. V is the potential difference between the two plates and D is the distance between the plates. Potential difference, that is 50,000 over 4 centimeter, that is 0.04 meter. So this is equal to 1250,000 joule, which is equals to 1250 kilojoule. This is the no kilojoule, sorry, this is not kilojoule, in kilojoule. Newton per coulomb. Newton per coulomb, or we can say volt per meter. Volt per meter is so this is volt per meter. እዚህ ጋር ይቅርታ volt per meter kilovolt per meter ማለት ይቻላል። ስለዚህ እዚህ ጋር ማስተካከያ ልስጥና ልለፍ። This is equal to 1250000 volt per meter. This is electric field strength. Next, B, the magnitude of force on the sphere treated as a point charge of 5 times 10 to the power of minus 9 coulomb. Here, force is equals to electric field strength times charge. So electric field strength is already calculated, 1250000 times 5 times 10 to the power of minus 9. 5 times 10 to the power of minus 9. So this is equal to, force is equals to 6.25 times 10 to the power of minus 3 Newton. This is the force formed between on the disk which is placed between the parallel plates. ሶስተኛው ጥያቄ, a second identically charged sphere like that in equation 2 above is tied to the top of pan balance by a vertical insulating rod. The charged sphere of question 2 is clamped vertically above the second sphere such that their centers are 4 cm apart. Show that the force between the two spheres acting as a point charge is about 1.4 times 10 to the power of minus 4 Newton ነው። እዚህ ጋር the force formed በፊገር መልክ ለማስቀመጥ እዚህ ጋር ፎርሱን ኦልሬዲ ያስቀምጦታል። ፎርሱ ይሄንን መሆኑን ቼክ አድርግ ነው። 1.4 times 10 to the power minus 4 Newton is already calculated force. So you ask her to determine the force formed between the two spheres is 1.4 times 10 to the power of minus 4 Newton. ይሄንን ለማሳየት ያክል ሁለት ፕሌቶች አሉ። ሁለቱ ፕሌቶች ላይ ዲስክ ሂር እንደገና እዚህ ጋር ሌላ ዲስክ አለ። ሁለቱ ዲስኮች የተሸከሙት የቻርጅ መጠን 5 times 10 to the power of 5 times 10 to the power of minus 9 እንደገና እዚህ ጋር 5 times 10 to the power of minus 9 coulomb charge. So the separation between the two is already given 4 centimeter. So እዚህ ጋር the force formed between the two spheres ነው የተጠየቅነው ማለት ነው። ያንን ለመፈለግ simply Coulomb's force ነው የምንጠቀመው። force is equals to k times q1 q2 over r square. So this is equal to k ማለት 9 times 10 to the power of 9 ነው። q1 that is 5 times 10 to the power of minus 9 q2 ማለትም 5 times 10 to the power of minus 9 ነው። ይሄንን ስኩዌር ማድረግ ይቻላል። the distance between the two spheres is 4 centimeter. that is 4 times ወደ ሜትር ስንቀይረው 4 times 10 to the power of minus 2 ሜትር ነው። ይሄንን ስኩዌር እናደርገዋለን። ፋይናሊ ይሄንን ቁጥር ሲምፕሊፋይ ስናደርገው ማለት ነው this is equal to 14.06 times 10 to the power of minus 5 ይመጣል። so this is equal to 1.406 አለው እዚህ ጋር since this is very small ይሄንን times 10 to the power of minus 4 ማለት ነው። ይሄ ማለት ይሄኛው ነው። ስለዚህ the force formed between the two spheres ይሄንን ቁጥር እንደምመጣ ቼክ አድርግ ነው የሚለው ጥያቄው። ተመሳሳይ ቁጥር መሆኑን ቼክ እናደርጋለን ወደ ጥያቄው ተመልሰን ማለት ነው። 1.4 times 10 to the power of minus 4 Newton። ስለዚህ ትክክል ነው ማለት ነው። next B the balance carried masses to the nearest 0.01 gram. The initial reading on the balance before the original charged sphere is clamped above the second sphere is 8.205 gram. Calculate the final reading in gram on the balance. The final reading in gram on the balance. So to do this question, force is equals to mass times acceleration. mass ነው እዚህ ጋር ካልኩሌት ማድረግ እንድናደርግ የተጠየቅነው። mass equals to force over acceleration. force ማለት አሁን ካልኩሌት ያደረግነው 1.4 times 10 to the power of minus 4 over gravity 9.8 instead of acceleration ማለት acceleration due to gravity ነው። ስለዚህ ይሄንን ቁጥር ለዚህ ስናካፍለው ስንት ይመጣል? 0.01427 ግራም ይሆናል ማለት ነው። ስለዚህ the final reading of the balance is equal to the final reading of the balance, the mass of the balance. The final reading of the balance is given as the mass which is calculated here. አሁን ካልኩሌት ያደረግናት ማስን መጀመሪያ ከነበረው ማስ ጋር በመደመር እናገኛለን ማለት ነው። the final reading of the balance is equal to 0.01427 አሁን ካልኩሌት ያደረግናት ማስ ነች ፕላስ 8.205 which is equals to 8.219 ግራም ይሆናል ማለት ነው። 9 ግራም This is the final reading of the balance. ቀጣይ ጥያቄ some details of the accelerating plates of an oscilloscope are shown over a leaf. Electrons leave the cathode with negligible kinetic energy. They are accelerated through vacuum towards the anode at 0 volt. Look, the electrons are emitted from the cathode, accelerated towards the anode. Initially, the acceleration of the electrons, when it is emitted, as soon as it is emitted from the cathode, it has negligible kinetic energy. Small የሆነ kinetic energy ነው ያለው ማለት ነው። መጀመሪያ emit ሲሆን small የሆነ kinetic energy ነው ያለው ማለት ነው። so ምንድነው እዚህ ጋር የተጠየቅነው ጥያቄ calculate the kinetic energy ነው የምለው። መጀመሪያ ምንድነው let's say this is the cathode where electrons are emitted, cathode, and these are the anodes, and the electrons are accelerated along this direction. Electron beam ነው ይሄ. This is found at 0 volt, and the cathode is found at 600 volt. Electrons accelerated along this direction. So you asked to determine the kinetic energy of the electrons. So to determine this, kinetic work done, you know that work done is equals to force times distance. Force ማለት electric field strength times charge ነው times distance. Electric field strength is equals to K times Q over R square. R square ማለት distance square. So substitute this equation instead of electric field strength because they are equal. Therefore, work done is equals to KQ over D square times charge times D. D is cancelled by 1D here. Therefore, work done is equals to K times Q over D times charge. KQ over D means potential difference. V ማለት ነው። KQ over D ማለት V ነው. Potential difference times Q, which is equals to work done. This work done is kinetic energy of the electron. ይሄ work done ማለት the kinetic energy, the energy ነው ይሄ energy ነው ማለት ነው because the electrons are accelerated towards the anode. The electrons possess, while it is in motion, it possesses kinetic energy. Therefore, this work done is equals to kinetic energy, which is equals to V times charge carried by electron. ስለዚህ ይሄ ፎርሙላ kinetic energy calculate ለማድረግ ነው የምንጠቀመው ማለት ነው። Therefore, kinetic energy is equals to potential difference times charge. So this is equal to potential difference እዚህ ጋር 600 አለን times charge carried by 1 electron 1 times 1.6 times 10 to the power of minus 19. This is the very small charge which is carried by a single electron. ይሄ charge ማለት small magnitude of charge ነው። ስለዚህ እቺኛዋ charge that is carried by electron, አንድ ኤሌክትሮን ይሄን ያክል charge ነው የምትሸከመው ማለት ነው። This is equal to 9.6 times 10 to the power of minus 19 joule. This is the kinetic energy of the electron. Kinetic energy of the electron when it is emitted from the cathode towards the anode it is accelerated towards the anode. Next, the speed gained by the electrons as they pass through the anode. The speed gained by the electron. Kinetic energy is equals to 1 over 2 mv square. So V square is equals to 2 times kinetic energy over mass of the electrons. So mass of electron is equals to 9.11 times 10 to the power of minus 31 kilogram. This is the mass of electron. So therefore V is equals to the square root of 2 times kinetic energy over 2 times kinetic energy over mass. So this is equal to the square root of 2 times 9.6 times 10 to the power of minus 19 over 9.11 times 10 to the power of minus 31. Therefore, V is equals to 14.5 times 10 to the power of 6 meter per second. This is the speed gained by electrons while the electrons accelerates toward the anode. The next question B. The electron beam passes through a pair of deflecting plates before hitting the fluorescent screen as shown in the figure. This is the fluorescent screen and the electrons passes through the two deflecting plates. ይሄ አንደኛው ዲፍሌክቲንግ ፕሌት ነው። ይሄኛው ሌላኛው ዲፍሌክቲንግ ፕሌት ነው። ኤሌክትሮን በዚህ ውስጥ ነው እያለፈ ያለው። በዚህ አልፎ ይሄንን ስክሪን ጋር ይደርሳል ማለት ነው። ስለዚህ ምንድነው እዚህ ጋር the electron beam passes through a pair of deflecting plates ይሄኛው አንደኛው ዲፍሌክቲንግ ፕሌት ነው። ይሄኛው ሌላኛው ዲፍሌክቲንግ ፕሌት ነው። በዚህ ያልፋል ማለት ነው። plate before hitting the fluorescent screen as shown in the figure below. ማነው የተጠየቀው እዚህ ጋር? ምንድነው የተጠየቀው? Calculate the electric field strength between the deflecting plates. በሁለቱ ፕሌቶች መካከል ያለው ኤሌክትሪክ ፊልድ ስትሬንግዝ ነው የተጠየቅነው ማለት ነው። ስለዚህ ኤሌክትሪክ ፊልድ ስትሬንግዝ between the deflecting plates ይሄንን ጥያቄ ኤሌክትሪክ ፊልድ ስትሬንግዝ is equals to V over D. V ማለት the potential difference between the two plates. This is the electric field strength. So change in electric field strength is equals to change in V potential difference over D. So this is equal to, let's say, V2 minus V1 over the separation between the two plates. So change in electric field, it is not uniform አይደለም ማለት ነው። በሁለቱ መካከል ያለው ፊልድ 250 minus into minus 250 over the separation between the two is 0.04, which is equals to 500 over 0.04, which is equals to 12500 Newton per coulomb. This is electric field strength between the plates. The last question number 5. Define Gauss law and describe the use of Gaussian surface. Gauss law መጀመሪያ Gauss law describe አድርግ ወይ ደግሞ ስቴት አድርግ። ከዛ ምንድነው ጋውስ describe the use of Gaussian surface. Gaussian surface ምንድነው ጥቅሙ ምለውን describe ማድረግ ነው ማለት ነው ጥያቄው። ስለዚህ Gauss law states that the electric flux through any closed surface is proportional to the enclosed charge. ይሄ ማለት ምን ማለት ነው? If this is the Gaussian surface and charge Q is placed inside this Gaussian surface, closed surface, there is a field line that is produced by this charge. በዚህ ቻርጅ ምክንያት የሚፈጠሩ ፊልድ ላይኖች አሉ። እነዚህ ፊልድ ላይኖች number of field lines is said to be electric flux ይባላል። ይሄ number of field lines is said to be electric flux. Therefore, electric flux is symbolized by this Greek letter is directly proportional to the charge enclosed in the Gaussian surface and inversely proportional to the permittivity of free space. So, according to Gauss law, electric flux is equals to magnitude of the charge over permittivity of free space. This is the mathematical expression of Gauss law. So, according to Gauss law, the charge enclosed in the Gaussian surface is directly proportional to the electric flux, and the electric flux is inversely proportional to the permittivity of free space. This is what Gauss law states. The use of Gaussian surface. This Gaussian surface is an imaginary surface. ምንድነው ይሄ ጥቅሙ ማለት ነው? አንድን ቻርጅ ፍላክስን ፕሮዱስ ታደርጋለች። ለምሳሌ አንድ ቻርጅ ኪው አለች። እቺኛዋ ኪው ፊልድ ላይን ፕሮዱስ ታደርጋለች። ፊልድ ላይን ኤሌክትሪክ ፊልድ ላይን። ይሄንን ኤሌክትሪክ ፊልድ ላይን ዲተርሚን ለማድረግ ጋውሻን ሰርፌስ አን ኢማጂነሪ ሰርፌስ ዴቨሎፕ እናደርጋለን። ይሄ ኢማጂነሪ ሰርፌስ ምንድነው ጥቅሙ? በውስጡ ቻርጅን ይዟል። ፊልድ ላይን ፍላክስ አለ። ጥቅሙ ምንድነው? ይሄ ጋውሻን ሰርፌስ imaginary surface ነው። ይሄ it used to determine the field lines that is said to be electric flux. The use of Gaussian surface, which is an imaginary surface, enables simple calculation to determine the field strength at any point on the surface, as long as the surface is ሲምፕል ወይ ስፌር ሊሆን ይችላል ይሄኛው ሰርፌስ ማለት ነው፣ ወይ ሲሊንደር ለሆነ ነገር ሊሆን ይችላል። ኤሪያው ስለሚታወቅ ሲምፕሊ ምን ማድረግ ይቻላል? it used to determine the field strength at any point on the surface, on the Gaussian surface. simply electric field strength በዚህ ሰርፌስ ላይ ዲተርሚን ማድረግ ይቻላል ማለት ነው easily። ስለዚህ the use of Gaussian surface is used to determine electric field strength on the Gaussian surface. በዛ ሰርፌስ ላይ ያንን ሰርፌስ በመጠቀም ኤሌክትሪክ ፊልድ ስትሬንግዝን ዲተርሚን ማድረጊያ መንገድ ነው ማለት ነው ጋውሻን ሰርፌስ። ስለዚህ ጋውስ ሎ ዲስክራይብ ስናደርግ Gauss law states that electric flux is directly proportional to charge and inversely proportional to permittivity of free space. ሁለተኛ ምንድነው ጋውሻን ሰርፌስ ጥቅሙ ኤሌክትሪክ ፊልድ ስትሬንግዝን ዲተርሚን ለማድረግ ይጠቅመናል ማለት ነው። ስለዚህ ለዛሬ ይዤላችሁ የቀረብኩት ይሄንን ይመስላል። ለዚህ ቻናል አዲስ የሆናችሁ ሰዎች ቀጣይ ቪዲዮ እንዲደርሳችሁ ላይክ፣ ሼር፣ ሰብስክራይብ እንድታደርጉ እጠይቃችኋለሁ። አመሰግናለሁ።